This last section on counting rules, called combinations, is dealing with this last situation where I'm picking some things out of some total number of possibilities, right? Like say I'm like pulling 5 cards out from a deck of cards, but where I don't really care about ranking or ordering or anything like that, right? Like it doesn't matter the order in which I get the 5 cards. It's the same hand, right, that I'm working with of 5 cards. And that's essentially what a combination is where we're going to start by looking at a permutation, and then how can we kind of like fix it in order to make it so I'm not treating, right, these 5 different orderings of my 5 cards that I get dealt as different things. It's all the same hand. So this is the situation where there's no real ranking, and the order in which things are selected totally doesn't matter. It all ends up being the same. Right? So let's back up a little bit to this question I asked with the permutation section. How many rankings of 4 cereals are possible from a list of 12? Well, this is just 12 permute 4, right? Which is, well, we've been through this already, right? Just 12p4. We can put that into our calculators. But what are we actually doing here? If these were my 4 favorite cereals, Cheerios, granola, Rice Krispies, and Lucky Charms, right? That calculation I just did treated these 2 different orderings that I have listed here as separate things, even though they have the same stuff on them, right? So this comes up all the time, right? If I'm just picking my top 4 favorites for my cereals instead of ranking the top 4, or if I'm making a grocery list, right? It doesn't matter if I wrote milk, eggs, and cheese, or cheese, milk, eggs, right? It's the same grocery list. It doesn't matter the order in which things are listed. It's still the same stuff. This kind of situation happens a lot, and that's when I want to use a combination. And I just need to think, okay, so I'm over counting by how much? Let's think about that. So if I've got 4 things that I'm picking from, and I want to treat any different ordering as really the same thing, I've overcounted by how much? Well, let's go one step further. What I'm overcounting is how many ways I could order these 4 things. How many ways are there to order these top 4 cereals? Well, that's 4 factorial, right? My top one would, or the first one I list, has 4 choices. And then the second one I list has 3 choices, and then 2, and then 1, right? So it's 4 times 3 times 2 times 1. It's 4 factorial. So that's how much I've overcounted by, and I'm going to need to divide out in the end. Sort of like how with the permutation, I just need to divide by a factorial to remove the things that I've overcounted. This is going to work just the same way, right? So how many ways can we put some selection of 4 things in my different rankings? 4 factorial. That's how many I'm overcounting if my question was not how many rankings of 4 cereals are possible from a list of 12, but how many ways can someone pick 4 favorite cereals in no particular order out of 12, right? Where order doesn't matter. The order in which they're listed doesn't matter. They're just their top 4. What I need to do is essentially just find that permutation and then divide by how many things I overcounted by, which here would be 4 factorial. So there's a formula for this. That explanation was just trying to explain a little bit of what happened here. If you remember the formula for permutations, so if I'm looking for the number of ways I can select R things out of N choices where ranking or ordering is important, right? The order in which they're listed is important, or specifically I'm like ranking them in a particular rank, and that was just N factorial. And then the extra things that I want to remove from that factorial are N minus R. You can go back to that permutations video if you don't remember how that worked, but there's our formula. Now, we also have this combination, which we're going to write as NCR, which is going to be n factorial divided by n minus r factorial, right? So it starts out as this permutation, and then I just want to remove, right, or remove from this counting process how many things I've overcounted by saying, oh no, a different order is a different thing. A different ranking is fundamentally a different thing. And that's where this r factorial comes in down here. Okay, so that's the only difference between these two. So they're kind of a little bit easy to mix up. But one way you can just kind of remember which one is which is that if ranking or ordering doesn't matter, there should be less of those. And so that's why this thing is down here. And so this permutation will always be bigger than the combination for these. And while we're at it, just know that you are very likely have a button for both of these on your scientific calculator. So make sure you know how to use those, because that will save you a lot of time entering in all these factorials.